Right, welcome everybody. Thank you for being here. Oops. To the 4th New Zealand Agentics Foundation event, and welcome to the online people from 𝗏𝗏𝗴𝗵𝗆. We'll be running a live Q&A throughout the session tonight. So if you're online, please put your question in the chat, and I'll read it out for Blair, who will be the main speaker today. I won't take up too much of your time. So yes, thank you very much to 𝗏𝗏𝗴𝗵𝗆 for putting on such a lovely spread and hosting us this evening. That's really lovely to have that. So Blair and I flew up to Auckland last week to give this talk, and went very well. We were very pleased with how that went. It got a great reception. And so what's the Agentics Foundation all about? It's a global community. It's a not-for-profit, and it's all about promoting the use of AI agents and sort of agentic workflows. And there's a big community there, right? And lots of kind of learnings and best practices coming out of that. So I personally see it as a huge potential for New Zealand, which is untapped. And so I launched the chapter here in New Zealand with Mark Vincent in Auckland. So you're very welcome to join us and contribute, listen, and learn as we go. Okay. So yeah, what is the Agentics Foundation? So really, I see it as a kind of a platform for us to showcase builds and insights, and really it's not about me telling you how things work. It's really, I think it's an invitation for you guys to come and share what you guys are doing as well. So it's connected me to a bunch of crazy smart people all over the world, and so that's there for you to learn as well. So we'll be hearing from Blair Nilsson today. He is, I would say, an agentic engineer. You'll learn more about what that means. He's working for a government agency, doing some pretty awesome things, fixing technical debt in new and inventive ways. And just a couple of things. So isn't this just vibe coding, right? Not really. So there is a bit of a difference. So vibe coding is totally cool, and it totally has a place. What we're doing is we're talking to AI using natural language, as most of you have probably experienced by now. But no code comprehension is really needed when you're in that space. You're embracing the vibes, and you're just going with the flow, and you're creating prototypes, and it's awesome, right? Now, don't scoff, don't dismiss it. It really does unlock some creativity, and I think, when we're working with non-technical people too, I think it creates a real opportunity there for collaboration. So, in contrast, agentic engineering is really a structured approach. We're using the same sorts of tools, but we're really about creating production-ready software when we're in this space. So yes, we are using natural language, but it's methodical, and still got to be ready for fixing lots of bugs. So some reality checks here. So look, developer expectations have changed, and there's a number of other factors going on here, but we do have a bit of an issue with jobs, particularly for the more junior engineers out there. And look, universities aren't really keeping pace with this stuff. They don't keep up with the curriculum, and it's moving so fast that I feel like there is a bit of a gap there, and that's a gap that I'm hoping organizations like Agentics can actually fill by just sharing that knowledge. And as a group, we're kind of learning as a group as these practices evolve. And so one of my goals is, how do we kind of tap into that incredible talent that's actually on the bench right now? So hopefully we can identify some pathways for our young IT up-and-comers. And part of that, I think, is there's this mindset shift. So if we look back 10 years, maybe a little bit more, depending on how you look at it, we're kind of in this cloud native space. So when we were there, it was all about infrastructure automation. So you could argue that that's kind of moving from ops to no ops, because we've automated that part. So when we're in that space, we're thinking about operations people becoming developers in a way, because we've automated that stuff. So this is sort of the inception of DevOps. Now 10 years later, now we're thinking about AI native. We're automating the code generation now. Okay, so we're kind of moving from devs to no devs. Now, devs are kind of in this concept, they're needing to learn to become product managers. They're not so into the code and how it works. They are learning to direct teams of agents that are coding for them. Okay. So I think if we sort of embrace that idea and teach the youth that idea as well, then they'll be in good stead. So how do we really unlock that 10x software developer? I think that really what I've learned from the agentic engineers who have really embraced this, and I'm talking about experienced developers who have really excelled and they're really getting great results, is that they've learned to stop focusing on the how, getting into the code and micromanaging the code, and they're just focused on what is it I'm trying to build here, and getting really crystal clear on those inputs. So the better your inputs are, and that is the specification of what you're building, the better your output will be. And really the lesson there is focus on the inputs. The output is cheap. So if the code is essentially disposable, just throw away the code and build it from scratch based on a better and better spec, and Blair will tell you more about that. So yep, the bottleneck has shifted to evaluation, and that's something that you'll see when you're creating all this code. Like, someone's going to have to figure out if it still works. So the shift is from the software developer to the agentic engineer. So here's a pretend job description I came up with, and really it's kind of a optimistic in some ways, but the idea is that, you know, we are really focused on deploying AI agents into production, and that are directly solving problems and shipping things and getting things done, and it's kind of a slightly different way of working. Now, there was actually a really great post from 𝗪𝗵𝗶𝗵𝗵 today. He's the president of the Agentics Foundation. I'm just going to read it to you because I think it really speaks to this and what I was saying earlier. And I promise, Blair, once I've read this, I'm going to hand over straight to you. So, those who cling to old definitions of their role risk obsolescence. Yet those who adapt to agentic mindset, who learn to build, deploy, coordinate AI agents, are not just surviving, they're accelerating. I think that might have been AI generated, that part. Now, as a single empowered developer, you can now achieve what once required a team. The ones who adapt are becoming the most valuable people in the industry. And so Blair will now tell you, what does that look like?
Everyone. Okay. I work for a government department. The department can get a little squirrely about its use in AI. We're still going through some stuff about it. But one of the problems that we've got is we have an awful lot of software written in languages that we rather it was not written. And so we have to be able to move these to a new to new platforms. And yeah, along the way we found some interesting stuff and found some really good ways of doing it. So that is what today's talk is about, which is how you've turned the software, you can port it to a new platform, as well as pulling out provably correct specifications. So not just, hey, can we get the specs? Can we prove that the specs are right? The answer is, you can, which is a little weird. Yeah, why would you do it? Mostly because you have to. We've got a lot of stuff that sits on SAS grid. It's expensive. We don't have SAS engineers. They're all retired. So we've got to get off it. But if we can produce the specifications, it means that we can just rebuild for any new platform. So if they come along, we're moving to Databricks, but if we wanted to move to Snowflake, we could just recompile to Snowflake specs. If we wanted to move to just like local stuff written in Rust, we could do that. If we wanted to move to a language like Julia, we could do that too. And we'd be able to prove that the porting process has worked, and that we can prove that the specification's right, which is cool. So how do we do it? In a real simple case, if you got some code and you had some kind of agentic coder, we're just going to black box it. But if you had something that said, hey, turn this code into this other code, and it would spit out some other code, it's probably wrong. And even if it was right, it probably wouldn't scale very well. Well, I know it doesn't scale very well. It's good for a function or two, but it just doesn't scale to really anything big. So even though the agentic coding tools are getting better, they really hit this limit very quickly, and you can't really deal with that. But if you wanted to make sure that it did port, good news is it's legacy code. You don't often hear people say, hey, good news, we've got a bunch of legacy code that we're porting. But legacy code means that we have a bunch of inputs and we have a bunch of outputs. It's been running for, good 20 years, which means that we can test it really well, because we can take 20 years worth of inputs and we can take 20 years worth of outputs, and we can go, does this turn into this? And if you can do that, then you can prove that the software, not that it's necessarily right, but you can prove that it would have worked for the last 20 years in the same way that the old software worked for the last 20 years. And that distinction is probably important, because once you get the specifications, often you'll take a look at them and go, hey, these aren't necessarily correct. But we'll get on to that. Unfortunately, our tests are not easy. While we can do a test, oh, sorry, I'll go back to the previous slide. Because one of the things you could do is that if it doesn't work, you can just rerun it. And you can rerun it, and it's like monkeys on a typewriter, and eventually you will have something that passes, in theory. The practice is that you will be waiting a very, very, very long time, and it will be very, very, very expensive. So you don't want to do that. And the tests are not easy. Or at least you're going to have to do some modifications for the tests. Because say, for instance, it was a pile of tables that you're pushing in and a pile of tables that you're getting out, then your previous code could be producing GUIDs, and that won't match. They could have the date that it was being processed on. That won't match either. They could, if you're moving it from a platform that's doing it in just row by row and moving it to something that handles, that's processing on a pile of nodes. You've got no guarantee that the ordering of output's the same. So your test is going to have to deal with this. You're going to have to do whatever modifications you need to do so that it is a proper test against your original to the output. And we can get floating point differences too, because you can have like one of these systems might be in 16-bit floats, the other one might be 64-bit floats. Like all bets are off about, like, you know, the equality is just like, well, if it's within a certain epsilon, then you're good. Otherwise, you're not. And so you kind of have to deal with that yourself. And if you don't have a pile of legacy data, you can use fuzzing to get around it. I'll talk about fuzzing later. Not too much about it, but just that it exists. And you can produce data that way. Okay, now, if you get your coder to do it in 2 steps, where it produces a specification and then uses the specification in the original code for doing it, this works better. Then you getting into as just an intermediate step, make some specifications. The specifications might not be right, but the act of making them, that it can, it's got some specifications along with the original code, then the target code is more likely correct. It's still not great, but you know, hey, it's better. And this is one of the steps that we took. Like when we were trying to get it to work better, this was a step. But it led to something really cool. So we decided to break up this production of specs. So we took our code, we told it to produce a specification from that code, and then we ignored the original code and used the specification to produce the target code. And then we ran our tests. And this is wild because it meant that if the test passed, then this specification contained everything that the coder needed to produce something that passed the test, which meant that the spec was complete. It meant that it was correct, or at least correct enough that an agentic coder can build something that is correct from it. And so it allows us to do a proof of the specification. If this passed, that specification was good, which is a neat trick, a very neat trick. And we're going to be continuing to build on this idea. So basically, every step that we're going to do, we're going to be making proofs that a previous step was correct. And as we can break the process down into smaller and smaller parts, as long as you can prove the previous step, you can produce this chain of steps from one side to the other. And from here, it's just optimization, because, hey, this will work eventually. It just won't work in anything like the time you need it to work. So we can take the specification that we've got and we can use it to produce target code. We can test it, and if the test fails, we can take the data from the failed test and push it back through one of the agentic coders, get it to produce some updates, and then merge those updates in. And this is really good because most of the bugs that we ran into, most of the complete failure, have to restart, was just stuff like it didn't put an import in. It screwed up some of the structure of the code, right? It was just stuff that would fail in compiling, or it would just it would make trivially fixable mistakes. And so by setting up this kind of loop, you can get it to produce you don't have to go through as many failure runs, because anything that was a close miss gets fixed, which is good. This debugger also can, because this debugger is able to see the failed results from the tester, and we're testing with production code, it means that this thing is getting exposed to production data. And that's its own horror. And so we have to run this. So the LLMs that are behind this have to be something that is secure enough that we can put production data through. So we can run them locally. And if we've got a local one that we can run, then we can put our production data through.
Do you have an example of a local box that?
Of course, I knew you were going to do this to me. So during our testing, this was our local box. So this was our LLM data center. It's a you'll see online stuff called there was a chipset that AMD put out for gaming called a 𝗪𝗲 𝗧𝗵𝗶𝗴𝗵𝗁. They actually make really good boxes. The other good ones are Macs that have got unified memory. So it allows you to load big enough data sets in, big enough, not data sets, LLMs in. But yeah, big enough that you can use it for the debugging stage, which is really neat. When we do the updates, we check to see if the updates contain anything that was has data in it, because we want to make sure it isn't, before we do our merge. We use the same LLMs. Yep.
Just the non-deterministic nature, like
yes,
updates. How do you go forward, not backwards?
Are
you inserting just small lines of code for the update, or are you letting it rerun the whole code base?
Oh, for the updates, what's happening is this is saying what this thing's putting out a change set, and then we patch the change set. It's a very, very small file, typically, right? Because it'll run through, it'll find a bug, it'll then do the rebuild, and then we did actually have this just patching the target code as well. And if you were only interested in the target code, that works really well. But we were interested in having a specification that we knew was correct, which is why we were doing the full loop rather than just patching the final code. But yeah, this could see the spec, and so it could produce a patch set for the spec, which was kind of neat. The other thing I would like to note is, do not at all let either of these be able to edit your tests, because they will. It knows that it should pass the tests. What's the easiest way to do that? To alter the tests so they always pass. Ask me how I know this. Because it's done that to me. The other thing is that this cannot be allowed to see your data set, because it will put the data set in the code to make sure it passes. Just like the horrors about this. This is not allowed to see your tests. Just don't let either of these see them. Nothing good comes out of that. But yeah.
Sorry, another question.
Yes.
You're kind of one-for-one, what I understand, one-for-one replacing a legacy application with a new one. So a lot of legacy things are very monolithic.
Yes.
Whereas the right thing to do might be to create multiple applications in a way that interacts, a better architecture.
Yes, yes. And in a few slides, we come to exactly this, because this really only works up to a certain size code base, and that size is still pretty small, and so that we had to fix things along the way. But yes, you have spotted where we are going. Do we have any questions coming in from Auckland? Yes.
So do you ever, for example, that spec stage, once that we generated, do you alter them line capture newly built business functionality.
Mhm.
Do you ever alter the specs manually? For example, because you're one-to-one, and for the last 20 years, you have a monster spreadsheets where you've got a couple of rules. You can now define there and let it generate code and test it and go forward.
Yes, and I will get onto that one later as well. The answer there is, yes, you can go in there and modify the specs later, but you have to be able to modify your tests so that they can test the new specifications. If you can do that, you're good. If you can't do that, only bad things are going to come from this. So, yeah. And in which case, when you're telling it to do the code, you don't just have the code, your current specification. You have these are the changes that we want to the specification document that gets put into this and connected in likewise down the bottom. And that allows you to change the stuff. Because one of the things that we found was when we could put out a provably correct spec, the first thing that people wanted to do was change it. They would read it and then they would be like, we want to change that. Oh, the other thing is about the specification document. You might notice I haven't actually said what kind of form it's in. Typically, when we were first playing around with this, we did it as a list of business rules. Like we just wrote out all of our business rules and stuff. We got it to produce, you know, low level. This is what each bit should do. But we also found that getting it to produce diagramming worked really well. Like the LLMs are more than happy to do diagramming. And the other way that the specifications could get produced that was also like surprisingly good was in Gherkin code. We just used Gherkin or Cucumber or whatever you want to call it as a way of doing specifications or a mixture. They work really good.
What's Gherkin code again?
Ask your BAs. They'll get that 1,000-yard stare. But anytime you see, like, you know, as an architect, I want to be able to blah 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 blah. You know, given whatever, that's good. There's kind of a formal specification for it, but this doesn't need to be in the formal specification. But it was a neat way of doing it. Okay, now I'll skip this one because the next screen has just got that.
I would add as well, if anyone online has any questions, please just fire them through in the chat and we'll ask them here.
Yeah. I don't want to lose people because if I lose them early, then I'm definitely going to lose them later. So if you have any questions, now's the time. My God, I've kept everyone in the audience. This is good news. This is good news. Okay, up here is really cheap. Down here is really expensive. In part, like this code generation part, that's expensive. The testing is expensive. If you're putting through a big stack of testing, that can be expensive. So one of the things that we ended up doing was we ended up producing, breaking up the tests to a little test, a medium test, and a full test. And we ran them in order. So we only ran the bigger testing once the little testing had passed. Because a lot of the time, the little tests found problems. And so we didn't have to go through a full testing setup to find that you'd missed, say, an import. Or that, you know, your requirements, because we were doing Python, the requirements text file was missing a requirement.
Why did you have to use fraud data for the tests?
Because prod data is all we had. If we had good test data, if we had a system where people had produced really good test data, then we would be able to use the test data. But in our case, we've got 600 projects we're moving, so we can either try and produce 600 sets of test data, or we can just accept the fact that we're going to use prod data.
So did you have to spend a lot of time writing tests primarily, even before you started with the rest of the process?
We automated the test stuff because we knew what was coming in. and we had a testing thing. We could look at the tables that were going in or looking at the tables that were going out. A lot of this was statistical analysis. The tests become much nastier. Like the testing stuff becomes much nastier if it's also emitting messages to other systems, if it's making calls out to other frameworks, if it's doing a lot of that. In which case, you're going to have to try and capture those and be able to produce testing around that. For us, because it was SAS code, we could sidestep a lot of that. So, but we do go on to how, yes?
All your eggs are in your test basket. How do you know your test is
because there really isn't a lot of ways that if you've got stuff which is, we put tables in, we get tables out. There wasn't really a lot of ways that could go wrong for us. And then if it passed the last 20 years of data, those parts that it didn't test, almost certainly that were badly written to begin with. Oh, we did. We most certainly did not have useful tests to start with, so we had to use. It was why we ended up using production data. But we'll get on to what to do if we don't have the production data, and how to deal with stuff like this thing's talking to other systems and stuff like that real soon now, because there's ways around all that.
So you generated this tests based on spec that was generated as well?
No, we generated the test data. Actually, I'll go back.
The test itself.
So the test really was. We've got the arrows from a long way. No one will ever hire me tonight. Okay, so we have so you've got a database that's got all of this data, and you run your process, and you end up with a database that has all the data that's come out, or your initial data has been transformed, right? Then you can start with this, run your program and get output, and you can run that on using the original code, right? Once you've done that, you've now got a previous state before we've run the code, a state after we've run the code, and then we can compare, we can write a thing that says, has this transformed into this? And yeah.
So when you started, you had the historic input and generated the output from the current code base?
Yes.
Okay, so you didn't have the historic output, or even if you did, you ignored it.
Well, we did have the historic output, and since the code bases hadn't changed for a very long time, we could use those. But if we needed to, we could just take the historic input and then just run it through there to produce the output anyway, which is useful if, for instance, your code base has changed over time.
Yep.
You might just want to pick up all of your historic input, shove it through there, and now you've got a good mapping for historic input to historic output.
As per the code base of today,
yeah,
regardless of what it might have been 3 years ago. Okay.
Yeah, and we also had to do it for another reason, because people would get in there and mess with the data on the way through. He says, looking displeased. Well, because there would be some exceptions in there, like and so they'd be like, well, we could fix the code base to deal with these exceptions, or we could just edit it every single time we run it by hand. As a good, organization who really, cares about developer time, we chose the second. And so being able to run it through to get yourself a clean output, like, very useful in its own way. We'll get on to how to automate that later. So now this starting spec, how good that is really determines how many loops you're going to do of this. And because this is expensive, we want to spend more time trying to fix this area up. Like, can we fix this so the starting spec isn't garbage? Because if we do that, whole thing runs better. It costs us less. We can get it done in an afternoon. Life is good, right? Okay. I think I just said all that. Oh, and if we can break it down into sections. Okay, so how we do it. We can ask it to generate the spec over and over and over again and then merge the results, because typically it doesn't hallucinate extra steps, but it does skip them. So that works. We can get it to produce the specification and then tell it to look back at the code and sees whether it matches. Doesn't always get it right, but you know, you can get it to update the code, but update the specification on that. This is all in the top loads because it's really quick. Running through these steps a bunch of times work. The one that worked really well was that we just broke the specification. We broke the code base down into parts, and then we ran the generation of specification over a whole pile of small bits, and then we combined them back together again. We'll get more into that as formal thing, but we did a combination of these. Oh, and the person who made a comment about it being probabilistic, you're in for a great time of it. Because we'll get into that too. Okay. If we could break it into sections properly, then we could run through each section through the build, test, update loop separately. Remember the person who said, hey, if we could break this up into a pile of programs and then connect them together and make a better architecture out of it? Yeah, that would be really good, wouldn't it? As it is, we can do that automatically, kinda, sorta, and that's a neat trick. But we need to know that the sections are correct first. So how do we break up the code into sections and then know that the sections are right and that this is how the code was broken up was correct? Like, we'd need to be able to do another proof. We would need to be able to find a way of breaking it up, testing the sections individually, and testing to see whether how they combine back together again. But we can do that. And yeah, this is our general pattern that we've seen so far. Do a thing, run a fitness test, redo it until you pass the guardrail. So we're going to do it again, but we're going to do it for breaking up the code. So we take our original code. We get it to produce a directional graph of how the bits of code go through there. So literally, hey, can you guys produce us an architectural diagram of our data flow, please? What's great is you can produce you can tell the LLMs are really good at producing dot format stuff, and 𝗏𝗏 is the other graphing language. And some of them will produce actual images, and that's okay too, weirdly enough, like SVGs stuff. And so you can get it to produce this, and it will use that as specifications, which is cool. We can then tell it to extract the code for each of the arrow paths. So we're like, please break this down. Now we've got our thing. We can run a splitter over it, and we can go pull out each section of code out there. Now, of course, we don't know if this diagram's right. And we sure as hell don't know if any particular piece of code that got brought out of this was correct either, which would normally make you sad. So what we do is we then use this and the sections of code, and we reassemble them. And then we run our original test across them. So this is still on the original code base. But this test will only pass if this diagram and these pieces of code can be reassembled into something that works. So We test to see whether we can split and reassemble. We don't have to do any code generation to do that. There are some horrors here, which I will get onto later, but mostly they're about if this path has some shared code with this path, it will each of them will generate code in its own right if you don't have any way of telling it to split out shared libraries and stuff. So you got to be really careful with the prompting and stuff on the stage, but you can get it to produce this these architectural diagrams and then use the architectural diagrams directly to as instructions, which is more useful than you would expect. Does it make sense that you can do this? Cool. And it makes sense that you can test it by reassembling it and then running it again. Cool, because we're going to be
found that sometimes if you have a deviation, one of the rewrites of the code is better than the other on the same piece of code.
Yes. Absolutely, absolutely. In fact, one of the things you might want to keep track of is how long pieces of code took to run. And in fact, when you've got a good specification, you might want to rerun it a bunch of times for like produce output, and then do testing that involves timings and stuff like that around it. And even then, you can end up with some really weird situations in some data platforms to do with ordering of output and how long it takes depending on various bits of ordering for the input to the next sections and stuff like that. So at that point, you'd probably need to get in there by hand and do some stuff. Yes?
So as you said, for this part, you haven't done any refactoring at this stage.
Nope, no refactoring.
You're just breaking up the original code and then putting it back together, making sure it still passes, right?
Yeah, yeah, and you can do this in an automated fashion is the important part. I am still looking at like works for researching. The stuff that we're researching in this area is that one of the neat things you could do is you could use abstract syntax for this. You could use an AST if you're going to get down with weeds, and splitting it up using an abstract syntax tree would be would yield more consistent results. There are other tools that can do code splitting and stuff for you. Again, we just proved it works, but we haven't found the best way of doing it yet. The other thing you can do is you can do it recursively. So once you've broken up an area there, you can then break that area up. If you do it too recursively, then you will end up copying exactly the structure of the original program, because as you dice it down to a fine level and then reassemble it in exactly the same way.
Sorry, you said earlier that the code bases that you were working across weren't very big projects.
They weren't very big projects, but they still needed, we still needed to split some stuff up. And I wanted to test what happens if we did some of the bigger ones.
How did you count them? Like, how did you count them by lines of code? Like, what's your definition of small, big, or otherwise?
This is going to sound really awful. The horror I had at opening up the thing and taking a look through it. Typically, our projects were still quite small in that they were somewhere under 20 files were involved for the code base. Some of the blocks of code were, in fact, however, quite large. There was a real mix of, because it was SAS, there was a real mix of code and SQL statements and stuff like that, because it's SAS. However, I have done tests on this on other code bases now, because I was kind of hoping, I wanted to know if it was useful for moving COBOL, because I knew a bunch of people who would be real happy if we could just port COBOL with the thing. And it actually worked, which was really neat.
What were they trying to port it to?
COBOL? They just wanted to know it could be ported. So we just tested, I just tested like random languages. Oh, thank you. You have helped me with in a way. One of the neat parts when we were doing that translation, if you're only interested in the specification, you don't actually care too much about what language you're porting it to. So you can port it to its original language if you wanted to, or you could port it to a language that was very, very fast for testing, but wasn't going to be your final destination language if you were trying to do tests. Also, if you've got this kind of split up thing, you don't have to port each of those steps into the same language. For us, because we're moving stuff from SAS to Python, there may be stages that we want to move to Scala because they'll run on the same engine and it'll be much quicker than Python, but we just don't have the developers for it. There may be stuff where we've got stuff written in even for our newer projects, because we're missing a lot of Python developers, but we've got like R developers, we may want to do porting on stuff that is actually recently written. Like they've just finished writing it in R, we want to move it to Python or something like that. And, you know, yes?
Did you pass in as well original documentation if it exists for code?
We did actually. We passed in original documentation and it helped, but we did have to tell the system that the code was the real thing and that it could look at the original.
You made the original documentation. Code base moves on.
Yeah.
Updates don't
Right.
occur.
So the code base had to be the authoritative one on there. But what was really useful about pushing the original specifications is that inside the code base, there's a lot of stuff where they have abbreviations. And in the original stuff, it has them filled out. Also, there's usually a lot of stuff in there about why the project is happening.
Speaking to the why, it might be self-evident for some people in the audience, but what was the benefit of breaking it down?
Oh, right. Because it is a whole lot better at porting small projects than big projects. And so if you continue your big project, you know, as the code size doubled, we found that the porting time took about 8 times as long. So by breaking it up overall, you ended up with a far shorter cycle. Also, I mean, the specifications were better. And because of the platform we were porting to, it's got a process flow engine. So we wanted to be able to turn it into a process flow. So this worked really well for that.
All right, so you end up with a specification for each chunk.
So we end up with a specification for each chunk,
yeah,
and a ported code for each chunk. And then and a way of, because we know that this is correct, a way of being able to then reassemble it if we had to reassemble it, or
so that,
use this as a way to produce the
whole loop that you presented earlier would run on a single piece.
On each part, yes. Yeah. So we'd end up doing lots and lots and lots of little port jobs rather than a big port job.
When you say chunk, you don't mean separate services, right? Like it's different areas within the same app.
Mm-hmm.
When you say chunk, you don't mean separate services. You're not decomposing it into separate services. So
No. I mean, you could tell it to decompose into specific services and try and do it the same way, right? How you tell it to chunk this up is probably dependent on what you're doing. We are doing a lot of data processing stuff, so it made sense for us to break it up this way. But you could tell it to break it up in any way that you really want to. All you need is a way to be able to break it up and then a way to be able to reassemble and test that it worked.
Sorry, question. You chose to generate the spec exclusively off the code. Did you contemplate some of the existing specifications of previous releases of that legacy application
We did it off the code as well as some of the specifications. It's just that we told it that the code was the authoritative part of it because, well, we kind of had to. It would have been interesting to see if handing it check-in information would have helped it along. I don't know. You know, this is, again, research. So we're still playing around. Yes?
You mentioned several times that you run these different flows to generate the code and then generate everything at the end. What if you do not want to do that? What if you, for example, have 5 flows, you're happy with 4, and you just want to focus on a 5th one, and you want to keep these 4 flows exactly as they are, and furthermore, use the pieces so that to assemble your 5th flow? Can you direct your agents to be that specific? To reuse your own code instead of generating code on the fly?
You could. Yeah, you could. As long as you've got a way of doing a test for it, then
you basically accumulate your past tests.
Yes. But yes, you could. There's nothing stopping you doing. In fact, you could use it for doing some pretty major refactoring if you kind of felt like it. One of the neat side effects that we had was we did something where we ported some of the code to its own code, to its own language. And in a shocking turn of events, the newly generated code was better written than the old code. So, you know, there is that. Yep.
On a spec, does kind of code could generate the non-functional aspect or just the functional aspect? Or can it differentiate? And how the test could do the non-functional test of like performance or security, how you
could do the non-functional tests, and one of the there'll be a talk I'll probably give later on when we picked up NZISM and turned it into a testing framework that we were running against our platform. So, you know, there's stuff like that you can do. But it's usually a bit of a different path down there. But you could make it that we're back when we were doing our test on up here. Back when we're running this test, you could put performance parameters in here and tell it to fail if it doesn't pass the performance parameters. And that would be able to get some non-functional stuff in there. Some of the stuff that you can do that's really good is you can get it to produce a fitness score if you're doing that. Because this is, so anyone here who's been doing AI for a very long time and is very old, you might have heard of something called genetic algorithms. Specification is your genome. Your test is your fitness test. This is your mutator. It's an evolutionary code base. And typically you make a lot of starting specs, and then when you're running them, you drop the ones that have got the lower fitness ratings and you take the ones that have got higher fitness ratings, and you find ways of being able to connect them together and stuff like that. So there's like 20 years worth of research papers that you could just like pick up and start applying to this process. I haven't yet.
We have a question from online from James. As well as existing documentation / specifications, were inline comments also included as non-authoritative guidance to help legitimate zero specs?
Well, we didn't strip them out. So yeah, they were in there.
What comments real programmers generate, not comments in thousands?
It's I am in this picture and I don't like it. Okay. Right. Okay. Once you've broken it up into fragments, you still need tests. So we'll get back to this. So once we've split it and we can test the reassembler, we can get it to automatically put code at the front and end of your split that says, hey, these are the variables that are being handed in and being used. And this is the stuff that's being returned. And then you can, or at least this is the state before it gets run. This is the state after it gets run. Can you please output them? Which means that you can get the test data even because you need to be able to get the input and output stuff for running a test for just a section. Really, all you need is the input. And the reason that you only need the input is because you've got the original code and you've got the splitter. You can run it and generate the output state. And then use the input state that you have at the top, the output state that's come out of the bottom, and then that becomes your test for testing that section, for any particular section of code. The other thing that you can do is if you don't have a lot of data, you can use a fuzzer for it. Who here has used fuzzers before? You have? Yeah. Yeah, right. Yeah. It's always there are systems that are really good at producing just really random stuff that's used for doing security testing against software. It's really good at breaking software. But it's also really good at testing all the different parts in software. So you can use those for producing garbage input. And then you can test that input. I say garbage input, but they're like just horrific stuff for trying to break the software. If it can pass a fuzzer, beating the tar out of it and taking the output of that, and you can apply that to the new one, and it comes through the same way. Then one, you'll know that it's broken in the same way. It might not be so good. But two, you will know that they certainly operate the same way, because it will produce an unholy amount of data for you to do testing on. Is it as good as your actual production data? Probably not, if you've got enough production data. But otherwise, it gives you a thing if you've got nothing else to use. Oh, when we did do tests like this, we ran through. Sometimes some sections just didn't have any data that flowed through them. Like we could take 20 years of stuff, we could put it through there, and just nothing showed up. Nothing. Whole branches, whole areas of code were never called in the last 20 years. When we looked into that, or when I looked into that, I found that the code was a bit on the flaky side because it never really had a good thrashing. My recommendation is you delete those parts. You just put an exception thing, an alerting thing saying, hey, we tried to call this. Yeah, you might want to do something about that. But if it hasn't been called in the last 20 years, it's probably not going to be called. This will make some people very angry to hear that. Interesting side story, though. So New Zealand Stock Exchange, NZX, their main system crashed one day. And the last line in there was, holy bat fuck man, how did we go down this branch? Now, the good news was that particular string did not show up often in their code base. So they could track it down pretty quickly. But yes, it had been running for ages, and then all of a sudden, bang, down it goes. I don't know much more than that. I just know one of the admins who were there on the day. And yeah. Yeah, he had words to say about it. But yeah, so there we go. Okay. Already talked about evolutionary computing. Yay. Yes, evolutionary computing. Oh, one of the other things that you could do is generate a whole pile of specifications and then throw out the ones that where the code base just blows out. That's actually one of the failure states of these agentic coders. Every now and then, like, they just get a wild look in their eyes and then they just start writing a humongous amount of rubbish. If you have one of the funniest things that I've seen, we were building some stuff and it kind of got a bit confused between JavaScript and Java and applied all of the enterprise Java patterns into JavaScript. I still have it. It's beautiful in its own way, right? But man, did it produce a lot of code. And incidentally, just in case some of you are architects and don't know, this is not the path you want to go down. So you probably want to keep track of how much code it's putting out, and if you have to favor one code base over another that's passing, pick the one that's smaller.
Before you go too much into that one, maybe you've moved on. James has another question.
Yes.
Now, focus. This is a big one.
Okay.
Clarifying your test comments as well as fuzzing, can you take an additional step to generate local code to generate externally safe, relationally consistent, obfuscated test data from production data? Did that make sense?
Yes.
Sorry, I'm sorry, I got straight. Would you mind reading? Is that James' question?
That's James. I'll let you read it.
Okay. The answer is yes. Yes, you can. And what we found was because this is something that our org has done a lot of, and we will get to that in our second to last slide. But it usually takes them a very, very long time. Is the answer. It's useful. It's great if you've got a tool set that will do it really well for you. We don't. And we've spent a long time trying to get tool sets that were good at it. Yeah, if you've got it, then that's great. If you're expecting your agentic coder to be good at it, the answer was it hasn't been in our tests, but maybe you'll work out a way to make it good. We haven't yet.
Just to get an idea, how long ago was this? Was this very recent or a few months ago? Yeah, the stuff that you guys did.
Oh yeah, recent. Okay, so I'll give some history to it. A couple of years ago, we got this problem lumped on us, and they said, "Hey, can you work this out?" And at the time, LLMs had a context length roughly of about 4K, 4,000 tokens, and we're very bad at it. They were awful. We still gave it a good college try by producing a thing that went through the code in parts and then tried to like fold stuff together. It was like how to turn something into, how to generate large documents off a pile of other large documents when you've got a code length this big. It's like it's like telling an ADHD kid to like try and tidy their room for like, and over a course of months that every day can you make sure it's tidy. It really didn't work very well for probably similar reasons. I can say that as a person with ADHD. Context length basically sunk us. And then last year we had another go at it. We had more context length stuff, and we could kind of get there a little, but it really wasn't good enough to really good enough to work with. And about 3 months ago now, we had another crack at it because we had like much better tool sets and the like, and this time it worked. So yeah, it's recent. One of the reasons that I'm going to go back in some slides. One of the reasons here that this is Agentic coder, some kind of Agentic coder with some kind of LLM behind it. We're not specifying this because when I wrote this, we've changed coders 4 times since then. We have changed which LLMs we use. We've changed, like, this is in flux. You will pick something good. But the process doesn't matter which one you're really using. It's just that some of them will give you better results than others. Some of them will converge faster to a working solution. Some of them will be cheaper. And, you know, we can have talks on that, but really, we're just trying to talk about the overall pattern involved because the specifics on the ground change so quickly.
So have you had this approach in mind that you've been iterating on for some time?
This approach?
Yeah.
No. This approach is actually relatively new, because we were doing this stuff earlier.
Right.
Because these weren't good enough.
Yeah.
So it was only once these became good enough that this whole process became possible. And as soon as we found that, then I was off doing crazy stuff.
You've mostly done this in the last 3 months. That's like really recent.
Yeah. That's really recent. The other one is that we've been told, so within our organization, like, we've proven it can work. We've proven that we can move pieces of software. We've done testing on open source projects on the outside world. We're in the middle of rewriting chunks of the framework and stuff like that. But what we've not done is actually moved anything into production yet. We will get onto that with my final screen, well, my second to last screen, because you have a screen after this. My second to last screen is, great, we can pop things really quickly. That's great. That means everything will go really quickly, except for the data migration, the business cases, the environment setups, downstream system changes, because, you know, your stuff's going to be pulling data from a new place now. The DevOps, yes?
Are you doing this in big bang approach, or we have feature plugging in the mix?
What's happening is we're picking some small projects to move. But yeah, I've big banged it. when we've been doing testing, I big banged it and left it running overnight. You know, here is the code base. Boom. Go. And then get back to it, you know, in the morning or in a couple of days. But it works, which is really neat. However, actually getting this into production, you know, downstream system changes, DevOps, architectural review, people want to mess with the specifications, and even getting approval to use the tool sets, right? You know, you can turn around and go to your, you know, government department or your bank or whatever and go, okay, boy, we can pop this stuff really fast now. We can do it well. We can prove that it works. Let's go. And they will turn it into a 5-year project. Right? The porting was the critical part, right? It used to be the part that took a long time. You would have to get a large team of people together. You would need to, you know, do a lot of stuff there. but it only took marginally longer than everything else. This doesn't really speed us up. At least for our stuff, because our code base was still relatively small.
It's just moved the critical path to somewhere else in the org.
Right, and so our question is, can we apply some of the same stuff to some of these other parts of the critical path, or like what kind of structural changes do we have to make to be able to make this stuff go quickly? It's not a panacea, right? It doesn't. It's good for the thing it does, but that doesn't necessarily, you know, kind of get you out of. It doesn't get you out of a tar pit. Like in a lot of our cases, we've got stuff that's been running for 20 years. Where's the data coming from? You might think that as an organization, we'd know, but we're going to have to do some archaeology. We're going to have to do our, you know, we don't know what's always running off the downstream stuff, right? If we go put this somewhere else, what other systems are going to break? Can those systems even talk to the new platform? Our new platform's in the cloud. We're going to have to set up bits whether they can talk across. Some of the data sets, like, are we even allowed to store them in the cloud? Are we, you know, et cetera, right? You know, hey, the fun never ends, right? That's why we got into IT in the first place.
Because we love organizational politics.
You work for MSD. You must love it. Or you wouldn't be there.
I won't get to that.
And I raised you our tar ocean.
Yeah, exactly. Like, you know which department I'm on, right? We don't have the same problems you do, right?
I can say what I really find interesting is that everyone wants to be specs, right? Everyone starts with it's in language X, and things would be so much better if it was in language Y. And the first thing you need to do is just get it into language Y, whatever the heck that is. Because you've already said, because we don't have the developers for language X.
Yes.
But as soon as someone sees specs, they kind of imagine themselves into the future where it's in language Y. And now they ask for all the business changes they always wanted, but didn't say until they felt they could. And now they feel they could, but you're not even there yet.
Yes.
Right?
Yeah.
It is amazing.
Now's my chance.
Now's your chance, right? But they're not like letting it get there and they're doing the incremental change that they said they wish they could, if only they had the developers, right?
Yeah. It's really interesting. And I am going to keep a chart. I'm not necessarily going to tell the people I'm keeping a chart of that, but I want to know how much and how big as the changes are from the architects versus business. Because I don't know which will mess with it more.
So if this was a language porting exercise, what is the architecture that could change? Is that just the way that it's modularized?
Well, the architecture could change if, I mean, the architects may have, let me give a fine example. Messaging. Like, how well do we know that this software is running? Like, do we have, you know, instrumentation?
Like logs and observability.
Yeah, right. Like, you could look at the stuff and say, man, we really need better stuff in there. And you could do that during the transfer. Like, that's a thing you can do, right? It's just going to take longer. And how do you test it, right? So in that stage, you probably take a two-phase approach where you port it and then you put in the stuff around it. But the question of like, does that happen as two different projects? What does the budget look like? Once the business has seen one thing port and it goes really well, what's the time frame for all the others? You know, fun stuff.
If the porting was successful, would the business see it? Because if they had a thing and now they've got the same thing,
Yes.
Do they actually, like, surely if it's literally just porting, the ideal situation is the business wouldn't see anything different. Or do you mean the bit of the business that has to pay the bills on the old stuff?
I think that if we're going to get into politics here, I think that the business will be yelling it from the rooftops. They would definitely be incredibly invested in the process. But also, yeah, there's stuff that they would want to change on the way through. There's a lot of stuff where they've got, hey, you know, we've got all of these specification changes that we wish we could do. We've gone down to IT. We've asked them to do it. IT's turned around and said, well, we've got one developer that still knows this language. And the code base hasn't been touched for 20 years. Let me work out what that will cost you. Writes a number down, shows it to the business, right? And it's like opening a curtain to a vampire, right? You know, the screaming, the hissing, the smoke that comes out, right? You know how it goes.
It'll take 18 months as well.
Yeah.
As someone in an identity, I think that it's the reverse problem, which is you just have stuff that's worked. The business has no idea, absolutely none of the value that you bring to the organization. And the only way for them to actually understand it is a couple of P1s.
Yep.
That is the only way. Yep. Until you have a couple of P1s and the whole lot falls over and you bring it back within half an hour, then they go, oh, this business critical thing that you've been asking for money, for upgrades or whatever, oh, but actually now we should do something about that.
I've got the best thing for you. Sorry, I am a software developer. We cause P1s. I mean, one of the things that we're trying to do here, and like one of the big things in Agentic Engineering is like what we're doing here is really orchestration layers, right? This is just an orchestration layer above a bunch of systems. And what we're doing is we're trying to make it so that this coder does the right thing. There's a number of ways that we can do that. And we want to know if the right thing is done, right? And we're trying to set it up as much as possible for success, right? We want to give it a small piece of code to port. We want to give it something that is, you know, that's inherently understandable, etc. Right? So a lot of this is like, how do we bend the world in the way that these tool sets are good at dealing with, in a way that these tool sets don't go wildly off the rails and building a bunch of stuff that you don't expect them to do. Now in vibe coding, that's there's your big difference between vibe coding and your agentic engineering. And vibe coding, you want them to go out there and do a bunch of extra stuff, right? You want them to surprise you. You want them to go above and beyond the call of duty. And in this case, what we're trying to do is we're trying to stick them down to doing a particular thing. One of the neat things you can do with this as a side effect, which we have done, is get them to produce what they think the specification should be. So getting them to look at it and go, well, you know, this is what you specified. Now, looking at what the code's doing and what the specification is and what the problem space is that we're seeing from the documentation, like, how would you change this? Can you produce us like a list of changes that you think would be good for this, right? And you can do it, and it works real well. Like, these systems are great at that kind of thing. But we don't want them to do that now. We want that to become a thing that we get a human in the loop to actually agree on later, and that we schedule and stuff like that, right?
So you said you use some different agents. Oh, you said you use some different agents over time.
Yes.
Have you found that the smaller agents are more trustworthy than large agents, for example? Is there a correlation there? So because it's kind of this race for tokens, right? Everybody wants a bigger model, more tokens. Would it be true in your experience that actually for this kind of work, a smaller token agent would be better?
We
Because it's
found
less
that
likely to hallucinate and drift.
I actually found that the bigger ones for doing this is a completely different talk, but let's go there. Okay, for data transformation work where we're transferring individual rows across, we really want small models, right? Because if you're doing it over a couple of million rows, first of all, you want it to be dead cheap, and secondly, the smaller models actually do the job themselves, right? But the moment that you get into coding, we are still not at the right size of the models for being able to do the job like really well. We haven't reached there yet. The models are going to get bigger. We're getting better small-ish models, can run on local hardware, like this box, and enough that it can kind of do the job, but the bigger models just basically, like, just way better. Like the Claudes in this world are better than your 𝗀 80 billion parameter things, and they just absolutely spank anything smaller than that, right? So for coding, generally you're after the biggest thing that you can get your hands on. So you were going to go on about the stuff that just got released, say, in the last couple of days?
No, I was just saying, like, thinking about models, right, and the way things are shifting, and even the models themselves are becoming more optimized.
Yep.
Just better at a smaller size. That pretty soon we might be at a stage where, you know, maybe in a year or maybe in 18 months, we'll have a Claude Sonnet 4.5, which can run on a laptop.
This is true. The other thing that we're seeing with the agent swarm stuff is that we're seeing individual things within the swarm are running on different models. Like that's just really started to happen. So if you're doing a thing where it's trying to like, oh, sorry, in a moment. If you're doing a thing where something is breaking down the task down into a pile of subtasks, that probably doesn't need to be your giant coding model. And so you can hand that off to something that's cheaper. If you've got something that's doing documentation, some of these models will be better at documentation. Some of these models will be better at coding. Some of them will be better at diagramming and stuff like that. And some of them are better at research. And so you're starting to see these tools take that into account and going off to different places. Our biggest shift, our biggest thing that we care about right now is whether they're local or remote, or if they are remote, whether they're remote of this type that is allowed to see that data set, right? But if you pick up the latest in agentic coding stuff in there, like Agentic 𝗏𝗏, which only came out a couple of days ago, it does break it down and send stuff off into wildly different LLMs. So you plug it into OpenRouter and it'll go off and use different models of different sizes for different parts of the process. And the chief advantage of that is it's cheaper. How well it works, I don't know. I haven't had a chance to really play with it yet. I'm going to be playing with it this weekend. We will see how that goes. Yes.
Thanks, Blair, for the presentation. This makes complete sense. Like, you have the starting stakes, then you obviously trial, and then you generate the code.
Yep.
I'm just curious about the cheap and expensive. What is it like from an order of what is it like relatively or loosely? What does it mean, cheap and expensive? What are we talking about?
Okay. The stuff that's up here, where we're just generating spec over and over again, right? We can do this,
it's
in a couple of minutes on a local box.
You're talking about token cost, right?
Yeah. Well, token cost and actual real cost, right? So say this test here, right, is running 20 years with production data. That's going to be expensive. Right? If you're up on a cloud service that's charging you for processing this, that's actually going like physically that is going to cost you and going to cost you a lot. Which is one of the reasons that we did this kind of thing where we would run it on a local box in a different language that was cheap to be able to shake out the specifications first, and then switch over to like trying to get it into onto the production systems. Just simply because we just want to get the cost down. I mean, it's still cheaper than your group of devs, but that doesn't mean that a little bit of bullshit politics that devs love to engage in, and I'm sure that project managers love to engage in too, which is, if we can get this below a certain cost, the approval process is wildly different. and thus, we want it under that cost. Yes.
A very boring question, but an important one.
Yep.
How did the CNA process go? How did you?
That is, you have chosen the worst day to ask that question. We are changing our CNA process. How did the CNA process go?
Sorry.
And the answer was, the old CNA process went really well, which was, can you just experiment on this? Go for it. Not using production data. Prove that it can work. Hey, we're going to do some stuff in the future. We've been talking through the new CNA process for anything to do with AI today. Made me a little less happy.
Did they do security testing and stuff for that? Did they do security testing? And
Yeah.
and all that before?
So, well, a lot of it was, can we do this inherently without causing, can we set it up in a way that it was inherently secure? And for our testing process, if we're using public data sets and public code bases, then we don't have to worry about tripping over our own orgs, code bases, and data sets, right? The initial testing has been done completely outside of the firewalls of the org, using none of the original stuff. Then we managed to get code bases that we were allowed to look at, and there was some stuff that had test data that was not production data, that we knew that the test data was still good. And so we were able to do tests on that. We've now got a new CNA process. It's really good, but we're still shaping out the details. But the CNA process is going to be more, some of the tools that we were allowed to use, the CNA Pro hasn't gone through the new CNA process. And so we've just been kind of locked out of a bunch of those.
But as part of SRA, they would have wanted to, someone had to do the code review and things like that, right? Like,
yeah,
to make sure there are no loopholes or whatever.
So for this, again, we were doing the testing on public data stuff. But yes, code reviews. One of the, yes, it has to go through a formal review process before we can run it internally. And that process looks like it is going to be a mixture of people and automated tooling and AI tooling. So, like lots of stuff around SonarQube, et cetera, like.
Yeah, I thought it would be a good time to go back to the time when you were seeking approval for the AI coding tools.
Yes.
And how you managed to get that across the line.
Oh, yeah. Okay. So for one of the things about how to get approval on AI tools, if you can do a talk, where the AI tooling is running behind you, typically, and they can see the amount of stuff that it builds in a short amount of time and how good it is, they will approve it. Secondly, if your security engineers start using the tool sets as like, hey, we're really interested in this, and they go off and start using the tool set, then they also tend to approve.
And the third part was using the NZISM as a spec.
Oh yeah. And we also did something where we just threw the we threw the NZ ISM specification in one of the tools and got it to produce a smoke test system for environments. And they were very happy to see that, because that stuff's really hard. Yeah, it's a whole thing.
And then you can have that as a repeatable thing that
Yeah.
you can just generate a report.
But that's for another talk.
Yeah.
That's for another talk.
It's a different talk, but yeah.
It's a different talk. But yeah. Anyway, I am going to go to the last slide because,
Yes.
well,
That is the last slide.
there you go. Now you should get up here and talk about it.
Okay.
Get up.
I don't have much else to say. Look, you've all seen a QR code before. You know how this works.